Welcome to our talk about the cost of Apache Kafka. We will take you through the way how you can measure the cost of your Apache Kafka cluster, and we will give you some tips and tricks on how to try to reduce the cost as well. If you don't know me, my name is Jakub Scholz. I'm a maintainer of the CNCF project called Strimzi, which is about running Apache Kafka on Kubernetes, and I'm super excited to do this talk with someone who I know for a long time and who was on the beginning there for my open source journey.
Hi, I'm Rajith. I'm the founder and CTO for Randoli. Jakub and I have been working for a while on open source, so it's a pleasure to be with him. These days, I spend most of my time around OpenTelemetry, OpenCost, and in everything observability. For folks who are not familiar with Randoli, it's the 5-second intro. It's an observability platform with a fundamentally different model. I'd leave it at that. Jakub, shall we get started?
Right, so on the beginning, let's maybe talk a bit about how your Apache Kafka cluster looks like. So it will definitely have some kind of control plane. I really hope that control plane includes the Strimzi operators, because Strimzi is the best, of course. But it will definitely contain either the Zookeeper node, if you are using some older Kafka version, or it will contain the Craft controllers, if you are using one of the newer version, which doesn't use Zookeeper anymore. And it will be always there, but to be honest, in our talk, we will mostly ignore it because it's kind of small compared to the brokers, and it doesn't really generate that much cost on its own. The focus will be really more on the brokers, which are the core of the platform. That's where the messages are being sent to, where they are stored, and where they are eventually dispatched to the consumers. And in Kafka, the brokers, they can be pretty big. Something like 64 gigs of RAM and 16 CPU cores. It's not unusual. You can have a lot smaller cluster. You maybe don't have 6 brokers, but only 3. Maybe your brokers are even bigger than that. Maybe you have 15 of them, 25. Kafka can handle really quite a lot. But in any case, there will be some CPU and memory which they will be consuming. And that's one of the sources where the costs come from. The next source will be the storage. Kafka is quite often used to store a lot of data. Sometimes they are stored for a very long time. So having the brokers using storage attached to them in the size of terabytes, it's again not that unusual. And it's another big source of the costs of your Kafka cluster. Keep also in mind that in order to get reliability and availability in Kafka, it's using its own replication protocol at the application level. So whenever you send a message to it, the brokers will automatically replicate it. Typically, you will have used something like replication factor 3. So a copy of the message will be sent to 2 different brokers and stored there. So that's also one reason why the disk requirements are so big. And then there are, of course, plenty of different network connections. The brokers, they need to connect to the control plane to get the metadata from the Zookeepers or Craft controllers to do some leader election, synchronization, and so on. But again, this is pretty small, so we can mostly ignore it. But then there will be, of course, the connections between the brokers, which are used to replicate the data between them. So, yeah, as I said, the way the replication works, a message will be sent to one of the brokers, and it will be passed as a copy to typically 2 other brokers, creating some traffic. And then, of course, the Kafka cluster will be useless if there are no clients, because you need something to send the messages there, you need something to consume the messages. It might be simple clients written in the consumer and producer API. It might be Connect instances. It might be Kafka Streams API instances, but of course, it could be something like Flink, Spark, and so on. And these clients, they will connect to these brokers as well. They will send the messages, they will receive the messages, and so on. So you can see this huge mesh of different connections. And if you really want availability and reliability, you will typically run across some availability zones. So you will have the clusters, the brokers, and the clients distributed across them. And the reality today is that still in some environments, Amazon AWS, you have to pay for the traffic which goes across the availability zones, right? So that will be kind of another cost which is being generated in your cluster. So the question is, when you have a Kafka cluster like this, how do you know how much it costs?
All right, so in order to look at that, let's look at the different categories of resources and costs that you need to track. First, you have the CPU, memory, and disk, which is based on allocation. What I mean by allocation is when you allocate these resources to your Kubernetes cluster, it starts to cost you from there onwards. And the second one is based on activity. When you have, when your brokers and clients starts to interact, they will generate, network traffic, and then depending on the cloud vendor, you will start to get charged for interzone or cross-zone traffic. So how do we, keep track of all of this? That's where OpenCost comes in. OpenCost is a CNCF project. And before I forget, there's going to be a project kiosk tomorrow at the Project Pavilion. I'll be there, and other folks from the OpenCost community. It's from 10:30 to 3 p.m. Check us out. So OpenCost, it does two things. Number one, it can calculate the cost of running a particular workload. It also can help you track efficiency metrics. So what do you mean by efficiency metrics? It helps you to figure out if you allocate a certain amount of CPU, memory, disk, how much CPU or memory does your application actually use? And that helps you to right-size your workloads, including your Kafka clusters. I've seen plenty of over-provisioned Kafka clusters, and in other cases where Kafka clusters don't have adequate resources. So using OpenCost, you not only can track the cost, you could also track the efficiency of the resources, and allows you to right-size your Kafka cluster. The way OpenCost works is it integrates with the Cloud Vendor APIs. If you are running on-prem, you can provide a custom pricing sheet. Using that, it can calculate the cost of your workloads, and that helps you to understand, get visibility into how much your Kafka cluster is going to cost you. So with OpenCost, there is obviously UI. It's a little bit limited, where what's really good about OpenCost is the model that it provides, the cost model, right? And there's a nice REST API. You have raw metrics in Prometheus that you can use. There's a Grafana dashboard. There's a Parquet exporter option, and there's a nice plugging architecture that you can use to build on top of OpenCost. All right, so what we did was we took an example scenario to kind of demonstrate this. So it's a 3-node Kafka cluster, and we generated some traffic here, and we ran it for about an hour. And this is what it looks like if you look at OpenCost, right? It tells you how much it costs from CPU, memory, disk perspective, and then using this Grafana dashboard, you can see that this is what the hourly cost is, and then based on that, it can tell you how much it's going to cost you for a week if you run at the same capacity, and then how much it'll cost you for the month. Now that you understand the cost makeup of your Kafka clusters, Jakub, can you talk about some of the tricks and tips that we can use to, reduce this cost?
Right. Let's think about it. So one of the things which is pretty expensive on your Kafka cluster will be the block storage, which is attached directly to your brokers. And if you are using one of the more recent Kafka versions, one of the ways how you can try to reduce the cost here is by using something what's called tiered storage. What the tiered storage basically does is that it will tell Kafka to start offloading the older data from the disks attached directly to the brokers and store them in some other, usually slightly remote storage layer. It can be, for example, some object storage such as Amazon S3. And because the data are offloaded there, You actually don't need the terabytes of disks on your brokers anymore. And they are pretty expensive usually, so you can save quite a lot of money if instead of 1 terabyte disk, you, for example, use just 100 gigabyte disk. However, it's not completely simple because the pricing model for something like Amazon S3 and the pricing model for something like Amazon EBS volumes is completely different. With the EBS volumes, you pretty much configure your capacity, your IOPS, and your throughput, and you get a fixed price per month. With the object storage, you pay for the capacity you actually use, but you also pay for every read and write request. So if you are using some use case in your Kafka cluster which doesn't really match well with the tiered storage. For example, if you have some data scientists running some jobs on it all the time, or if you are using it to train or test some models, which basically force the cluster to read the data again and again, the price can be actually more expensive than the local storage. So that's why in this case it's really important to know the cost. And also, if you, for example, find out that the cost of the object storage doesn't work for you, you can consider alternatives such as shared NFS storage. But the cost monitoring is really important here. So how do we monitor the cost for this?
Yes, and you can use OpenCost again over here. I already showed you in that screenshot that you can look at the cost of your block storage. If you're using S3 or blob storage, OpenCost allows you to integrate with external costs, but you would have to do some additional work to attribute that cost to a workload. It's not done automatically, but you can still at least get visibility into the S3 storage. Right, now that we've looked at the storage side of things, shall we talk about the network cost side?
Yeah, so one of the other things where we can maybe try to save some costs are the network costs. And in particular, we can try to reduce the number of the connections and the data being sent over them, which go between the availability zones. So where can we do it? We actually can't do it for the connections between the brokers and the control plane, because that just goes to the control plane leader, and you can't really configure it. So we actually don't mind, because that's not that much data, it's not that huge throughput. But we can't really do anything about the replication between the brokers either, because if you remember, we are replicating the data across the availability zones to make sure that they are actually available when one of the availability zones goes down. So yeah, there's no other way to do it than to actually replicate the data. So I guess we will need to save something on the clients. Now, with producers, we can't do much, because the producers, they're always sending the messages to the partition leader, and in whichever zone the broker is which hosts the leader for the given partition, the leader replica, that's where they will send the messages. But for consumers, you can actually configure the consumers to consume from the brokers in the same zone. So if you have the broker rack configured in your brokers, and if you have the client rack configured in the clients, you can configure in Kafka something what's called rack-aware replica selector. And thanks to that, the consumers will actually connect to the replicas which are not necessarily leaders. They might be even followers, but they will be hosted in the same availability zone where the actual consumer is running. And that way we kind of get rid of all these cross-AZ connections. The price will be that the latency might be slightly higher before the message reaches the consumer. But just keep in mind that we are not talking about like waiting 5 minutes for the message. It's more like a few milliseconds later than if the consumer is connected directly to the leader. So yeah, that's one of the ways how to save some money. And how can we measure it?
Yes, some great tips there. Network cost can be substantial if you have a very busy Kafka cluster running on a cloud and in a multi-zone arrangement. It can cost you quite a bit. So how do you get visibility into that? Now, OpenCost by default does not measure network activity, so you won't see that cost, but it does have all the data structures in place if you can calculate the relevant metrics and publish it in a way that OpenCost can make use of it. So one trick that you can do is to use a network, a library that can actually track network costs. So in this case, NetObserve, it's another open source project. You can use that to help you not just monitor and visualize, but also kind of grab those metrics, and then you can publish that into Prometheus in the form that OpenCost expects. It works based on eBPF, pretty lightweight. Folks from Red Hat are behind this particular library. So this can help you get visibility into your network traffic. And by using these metrics, you can now identify if the communication between two different pods, are those pods in the same zone or a different zone? Based on that, if you tag the data properly and calculate it, now you can get the metrics, how much cross-zone traffic is happening, how much is within the same zone, and then based on that data, you can publish that into Prometheus where OpenCost can make use of it. Right. Now that we keep track of all of this, what are some of the things to keep in mind, Jakub?
Yeah, one important thing to keep in mind is that the consumers, they don't just consume the messages. They also need to commit the offsets of the messages they already processed. They sometimes, when they are starting, they need to read the initial offsets. They need to sometimes update the metadata about the cluster and so on. So in the diagram I showed in the beginning, which nicely showed that the client is connected only to the brokers in the same zone. If you would try to get the same in the NetObserve topology, it probably won't look that nicely because there will be these connections for committing the offsets and getting the metadata, which might go across the zones. But if you then check the traffic flows, then the bandwidth consumption, that should be within the same zone, and the other connections should be pretty small, just with some minimal data. So yeah, that's something to keep in mind. Now, another thing which you can try to do to reduce the cost is you can try to scale the Kafka cluster up and down according to your demand. Now, Kafka is stateful application, and the brokers are holding the data. So the scaling is not as simple as with some stateless application where you scale it up and 10 seconds later you scale it down. But you can still do this with Kafka. It just needs to kind of move the data to the remaining brokers before you scale down, and then after you scale up, it needs to move the data back to the new brokers to balance the load. But you can, for example, do something like this, that on Friday evening, when you know your applications will have a lot less load because people will not be working over the weekend, you kind of scale it from 6 brokers to just 3, and then Monday morning you scale it back again to 6 nodes, because Monday morning people start working, your application will be again under the load. And you can similarly do it, for example, overnight, during some holidays, depending on really what the characteristic of your business is. It's not completely free because you need to move the data, but in a way, this works pretty nicely with the tiered storage, because the tiered storage reduces the amount of the data which you have on the brokers, and that actually makes the scaling easier and faster. I actually did a talk last year in Salt Lake City about auto-scaling Apache Kafka with Strimzi. So if you are interested more in this topic, then you can check the recording of this talk from last year. And let's at least briefly touch on some other options which you might have to reduce the cost. One of them is to decide whether you really need to use free availability zones, whether you really need to use replication factor free, because Kafka is often used also for data where the availability and reliability is not absolutely critical. It's sometimes just some metrics, delivery log messages. A lot of people consider these data ephemeral and don't really mind if they get lost. So if that's your case, maybe you don't really need to run across all the availability zones. Maybe you don't need to have high replication factor. Another thing is that if you are running a small Kafka cluster, then with Craft, you can use these combined nodes where you have the broker and the controller in the same node and they share the resources. And that can actually save you some resources as well. And finally, a bit more looking into the future. There's some discussion in Kafka about something what's called diskless topics, which kind of takes the tiered storage to yet another level and uses the remote storage such as Amazon S3 as a store for all the data belonging to the topic. And that way you can save even more costs on the disks attached to the brokers. But there's potential to even save the cost for the replication because if you are relying on the availability and reliability of the Amazon S3 storage, you don't necessarily need to replicate the data within the Kafka cluster itself. So that has quite a huge potential to save the costs as well. And we are slowly reaching the end of the talk. So what are some conclusions?
Yes, absolutely. We showed you how you could measure the cost of Kafka using existing open source tooling. Yes, there's a couple things you have to do yourself, like but it's still doable, and those tools are fairly useful if you can put them together. And then I think if I had to summarize a couple things that Jakub mentioned, you have to take a closer look at your Kafka use cases because not all use cases are the same; they're very unique. Try to identify your situation and then pick the right strategies that we talked about. Otherwise, if, for example, if you use the tiered storage in the wrong scenarios, for example, where you have a data science team reading a lot, that can actually end up increasing your cost, right? So find the right strategies based on your use cases that would work for you. I think we've come to the end of it. I think we've got a couple of minutes for some questions. Yes, sir.
So I have a question from your example in the early that you have multiple clients connected to the Kafka. So in this solution, is there any way we can know the cost for each of the clients, or maybe even each group of the client if they share the same label?
Yes, you can. With OpenCost, you can track at the individual pod level, application level, and also using labels, you can aggregate across a group as well. So it's possible, yes, sir.
Including the storage and the network?
Yeah, absolutely.
No, maybe just to clarify, like there are two different things, I think. You can track how much the actual client is costing you, but I don't think it's that simple if you would want to kind of know what's the share of the costs of the Kafka cluster, which belongs to this particular client. Like this.
That's my question.
Yeah,
Okay, gotcha.
I don't think that's that simple currently, yes. But yeah, maybe that's an interesting topic to work on.
Yes, yeah, you can just only measure the cost of that because it may be talking to other applications too, right? Yeah. But the share of like how much it talks to the Kafka cluster, you can.
Yeah, in our case, that some of the client may consume by accident consume a lot of resources and they don't even know. So we want to. So we receive the bill at the end of the month and want to know which customer is making. Having some issue with their program. So that's why I'm asking.
You can't see that right now.
There are, I mean, in terms of CPU and memory, you can, but in terms of network traffic, you can, because you can figure out, based on the network metrics though, you could peg the traffic that goes between the clients and the brokers, but not in terms of CPU and memory.
You say that not in the CPU?
No, yes, because that application may be doing other things, right? So how we can really allocate that. But network traffic, yes, you can.
Network, okay. Yeah. Thank you.
Any other question? Thank you very much.